Hi, everyone. Thank you for joining us today. My name is Danielle Parker, and I'm the Executive Director for the Preservation Alliance of West Virginia. I'm joined today by Derrick Smith and Jon Smith, who are our experts for today. Just a couple logistical things. If you have any questions throughout the webinar, feel free to send those in either through the chat box or the questions tab, and we'll answer those at the end. And to get us started today, we'll be talking about a question that was submitted from a residential property. It was a house built roughly in 1940. It has a brick veneer. So our experts will be telling us a little bit about dealing with masonry and some other surprise topics as well. So I'm going to hand it right over to Derrick and Jon. Thank you both for being here with us today.
Hello. As Danielle just mentioned, we received a question through Danielle and some photos of a house that was built during the 1940s that is a wood frame structure with a brick veneer. And a lot of the problems that are in these photos we're going to go through are pretty common to that type of construction. So let's jump right in here. So as we can see here, this is one of the most common problems. Masonry veneer construction, sort of the first documented case that I could find is in the middle 1700s. Prior to that, all masonry structures were basically solid masonry structures. And so at that time, they started playing with the idea of applying masonry over top of different type of construction. And it kind of went, as all construction does, you sort of learn as you go. And so this structure was built, as we said, in the 1940s. And by that time, this was fairly commonplace. And so what you see here in this photo is a window or door opening. And in order to span across this window or door opening, there's a metal lintel in here. I'll skip ahead a little bit here. This is what is inside of that wall. And what happens is, as moisture comes down along this wall and runs around here, if this is not kept caulked and painted, this metal lintel begins to rust. And as metal rusts and aluminum or iron oxide is formed, it expands. And that expansion can actually cause what you see here, this masonry to split, especially during this time. In the 1940s, 1930s, we had really started to use pre-mixed mortars in this country. And so we end up with a lot harder Portland cement-based mortars than the previous lime-based mortars. These lime-based mortars were soft and pliable and would allow a lot more movement within a building. And so at this time, you end up with a lot more rigid masonry. And as we'll move through these slides, this sort of is what I just talked about, the displacement of these elements. And this is both of these photos are of the person who asked this question's building, and you can kind of see in both of these pictures. Can you guys see my mouse moving on the screen?
Yes.
Okay. Great. So right here, you can see where the metal is expanding, and as that metal expands, it's pushing this brick away from this brick. And since these bricks are all adhered together with this very high compressive strength mortar, it splits and cracks and separates from the brick and causes the sort of problems that we see in these photos. And really, it's strange now to think about it, but in most of the country until before 1990, it was not code to use any sort of rust preventative measures on this. You know, we've sort of gotten away, and that's with a lot of these problems. We've gotten away from a lot of the maintenance that used to be practiced in buildings. And so now a lot of people assume anything that's an exterior product just lasts forever with zero maintenance. And when it goes bad, you just sort of replace it with another zero maintenance product. And that's not really the case. The caulking and the paint and everything around these windows needs to be maintained, or otherwise this is the type of thing you can have. And as far as masonry repairs go, this is not what I would consider a major repair, but it is something that's probably going to require a professional mason, and there's going to be you sort of have to support the masonry above, and there are some concerns. You could really mess around and cause a failure within this wall if you try to replace this yourself. And so this is something I would definitely recommend consulting a mason who deals in historic structures for this type of problem. And so here you can see that this old rusty lintel that we saw in the last picture has been removed. And I can't tell whether they've cleaned this up and painted it or whether this is a new one. It actually looks like a new one. But as you can see here, it's had a coating applied to it that should stave off rust for a lot longer than just a piece of bare steel. Another problem that was in the building, this same building that was submitted to us, is where I think there's an addition here, or it's two structures that are joined together, and this mortar joint in between, this vertical mortar joint that runs the length between these two buildings has failed. And that is just due to, again, as construction has evolved, we realize that there's a lot of differential expansion between the underlying wood structure and the brick veneer. And so nowadays, the National Building Code will not allow you to go more than 25 feet without a vertical expansion joint and a control joint, as they're sometimes called. And so this is sort of just a thing where at the time, this was the practice. It's no longer really the practice. And there again, had it been a soft, pliable mortar, it probably would have held up for a while. But this is sort of another just maintenance issue where once in a while you have to retuck that joint. Nowadays, the solution for this would be to cut that vertical joint out and apply backer rod and a sealant. So it would allow the buildings to move independently of one another, and that sealant would stretch and allow the buildings to move without this cracking that you see in this photo. And there are several photos of this building where this is the case, where they either joined two buildings together or there's an addition, or perhaps this is an early control joint. And here's a modern building, and you can actually see right here, I've highlighted. This is an intentional vertical joint that runs the length of the building. And you'll see these on all modern buildings if you look, whether they're solid masonry buildings or veneer buildings. About every 25 feet, you're going to notice this control joint that's not mortar, it is actually sealant. The other problem that this building exhibits is some differential movement within the foundation. As you can see here, there's a cement block foundation that's showing some cracks and some movement. And these cracks are going to telegraph up into the brick also. And this could be a major problem, could also just be a minor problem. Most generally, this building's say 80-ish years old. And in that amount of time, especially in this area, I mean, you're just going to get some movement, some sliding of the terrain surrounding the building. And in almost all these cases, that's not a sign of any sort of catastrophic failure or foundation failure. It's just sort of something that happens as the building moves along. And typically these cracks can be repaired, and it's just sort of maintaining the structure. One good way to figure out what's going on with that, there are a lot of products out there. This product, as you can see, is a crack monitoring device that you can just order online. They're inexpensive. I'm not sure off the top of my head what the price is, but they're cheap. And as you can see here, you apply these. This is actually two pieces, and this has been adhered to a building with, I'm guessing, some sort of epoxy. But one piece has a grid on it with markings that are either in metric or standard. This particular one's in metric. And so this piece gets glued on one side, and then the other piece has this red cross on it that corresponds with the center of this grid. You line these up when you glue them on, and then you can just kind of come back maybe once a month, once every 2 or 3 months, and snap a photo nowadays with a smartphone, and perhaps hold up a card with today's date and time on it, and just sort of monitor this. And this will easily tell you whether you have current movement or whether this is just some sort of past movement has stabilized. And you know, if you monitor this for several months, maybe 6 months, and this thing doesn't move at all, there are no underlying structural problems. If you start to see a lot of movement here, then obviously the underlying problem always needs to be repaired. And that's for any of these problems that we've shown thus far, and most problems in a historic structure is if you don't fix the underlying problem, then fixing the superficial cosmetic problem is going to do no good, and it's going to just constantly reoccur. And that is really important with a foundation problem like this. If there's some movement going on, then that movement needs to be stopped. Especially in a modern brick building like this one, where we're talking about high strength mortars, where they will accept very little movement without showing cracks and other things such as this.
Yeah, one other thing. What we used to do prior to the magic phone cameras is you just get an index card and set it across the crack horizontally and mark both sides, and then vertically, so it looks like a tic-tac-toe board when you put a little pencil mark on there. And then you write the date on the card and put it away. And then a month later, you can lay the card back there again, and you can see if there's any movement. And you write the movement down on the index card, which is that's kind of the old, prior to technology. The other thing is, when this house was built, there was during the days where they excavated a big hole and laid a foundation and then backfilled around the foundation. So a lot of times you'll see stairways, concrete stairs that have settled because the French drain around the house is settled. And so a lot of the problems with stairs that come down like that are just simply where the French drain is settling in and not that big of a problem. They can be jacked back up into place and grouted under or just replaced. There's a couple of things to consider when you're looking at cracks such as the photo. Go ahead.
So far as this house is concerned, I think I hope we've answered all the questions. Is there anything else, Danielle, you want on this particular topic? We can go ahead and answer any masonry questions now before we move on to a different topic, perhaps.
I do not have any particular questions myself, but we can give folks a minute to send in questions, or they can raise their hands and I can also unmute them if they have anything that they wanted to ask.
Sure, and then we can just talk about some general masonry stuff for all historic masonry structures.
Okay.
So if no one requests to be unmuted, I can move over.
No, they haven't yet. So if you want to keep going, feel free. And if anything pops up, I'll let you know when there's a break.
Okay. And so this, with any of these problems, as we've shown, if once you decided you fixed the underlying perhaps structural or water problems and you are ready to repair the mortar and fix the brick, one of the most important things, and this slide show here is all basically based around the National Park Service's Preservation Brief number 2, historic mortars. And let me get this in slide presentation. Okay. And so one of the most important parts is matching the mortar. And as you can see here, there are a lot of places you can actually send mortar off to have a professional match and have a laboratory examination. But for most cases, that's not really necessary. There are a few things that you really want to watch and are important. And these are sort of the highlighted points from that. The most important 3 characteristics are the color, the texture, and the tooling. As long as you match those 3 things, your repair will go largely unnoticed. sort of blend things in. If one of those three things is off dramatically, then the repair is going to stick out like a sore thumb.
What it looks like is that everybody's seen it. Everybody went down the road and seen a building that's been tuck pointed with the wrong color, and it looks like a Dominic chicken or something. It really sticks out like a sore, it sticks out bad. So the sand match is the key thing, but to get the stuff to match is key, both in looks and also in strength, so that they all expand and contract at the same time.
Let me show a photo of, we just did a masonry workshop.
Sorry, y'all. It looks like we got disconnected for a second there.
I'm still here. I'm just looking for something, and I'll bring the screen back up.
Okay.
There you go.
Let me get this open. Okay. Now we're back. I'll let you talk a minute about where this.
So here we're down on the Tug River, down in Welch, West Virginia, and doing a masonry workshop, and we're trying to match existing mortar. So I'm looking around, and basically that building was built around 1916, and in 1916 you would just go get the sand at a local source. Right previously to the workshop, there'd been a flood and deposited a lot of silt and sand on the walkway down the Tug River, and the city had cleaned the sand up, and piled it up at the south end of town. So I said, you know what? There's a lot of coal in this mortar, and if you look at the mortar sample there that was dug out, you can see all the little black specks. And I said, there's a lot of coal in this southern West Virginia sand. This isn't anything that came from Lowe's. This isn't anything that was dredged up anywhere. It's just local stuff. So we went down, took a couple of the students, went down and got some sand, just picked up some sand, local sand, and of course checked that it was clean, it was free of silt, and brought it back and put it out on this board and held the mortar sample up. And you can see it's just exactly what they used in 1916. And you can see how the mortar is going to end up after it cures. After it cures about 6 months, the mortar is going to end up where it's pretty much indistinguishable from the existing mortar. So it's going to look, the blend's going to be almost perfect. The large white spot in the mortar sample is lime, and that was burnt on site limestone, where they had a lime burn, and they gathered up a bunch of limestone and burned it and then slaked it and made the lime for the mortar. So basically this mortar was made entirely right within a mile where the building was built. The whole components, all the components for this mortar mix. What a beautiful job it is when you can come together, when everybody comes together and you look around and you find your materials and make such an excellent match. It goes back to it was all preservation, especially masonry. Before you can just look in the town. Just look up the town. And when the railroad hit town, anything before the railroad was basically material at hand. The lumber was material at hand. The masonry was material at hand. I've said a lot before 1852, when the B&O Railroad put a railroad to Wheeling and connected the Ohio River with Paris, France. Every building in the United States was built with the same material, whether it be adobe in Southwest or stone in the Northeast or log cabins in West Virginia. Every building material, every house was built with materials at hand. So a lot of the times you can just go locally and source a lot of your materials to restore these buildings. And it does a lot better than, say, mailing it off. Had we took that mortar sample, and we could have taken that mortar sample and sent it off to Limeworks or any other lab around America, they could have made that match, but they had no idea that the sand came from 2 blocks from the building. And if you look around, you can sometimes solve a lot of your problems just with simple observations and dating things. If you go back and look around at the dates that the town was established or the building was built, and what kind of sources did they have? And most of their sources were rudimentary. It was pretty close, pretty easy to come back and replicate just exactly what they did. It's just really not that hard. But this is key. If you see that, if you're looking at that picture and you're seeing the closeness of that sand and the lime, that you can just about tell what that's going to look like after it completely cures.
Oh yeah, the sand is by far the largest component in any mortar, both historic and modern mortars. And so that is going to be the key for matching any of this stuff. As I mentioned before, all the information within this PowerPoint is available on the National Park Service's website. They're referred to as the preservation briefs. They're a great source for homeowners and really anyone with a historic building to find information regarding a variety of topics. So, all right, well, from there, I mean, if no one else has any other questions, we can move on to some wood siding stuff.
Okay, yeah, no questions have come in yet.
Okay, no problem. Okay, so this is a different customer, acquaintance of ours, I guess, is building. And as you can see, as we move through some of these pictures, there was a box gutter that, as with most box gutters, failed and caused a lot of water damage and rot to this building. And they were having a really hard time finding this narrow siding. This siding, if I can move through this photo, it's not your typical 4 to 6 inch siding. You can see here this stuff is about 2 1/4 inches of exposure. And I'll let you go from there, Dad.
Yeah, this was a box gutter leak, and they contacted several local roofing companies, which basically, aren't familiar with the box gutters and the build-up gutters on a house. And this is a Victorian shingle house, and the box gutters are basically, made out of the ceiling joist from the top floor. They extended them out. They extended the ceiling joist out about 1 foot over the side of the house, and then the rafters came down at the edge of the house. So the carpenters then would put a string line from one end to the other, and then lower that string line, whatever the pitch they wanted to be. If they wanted to drop it 2 inches, they would drop the string 2 inches at the end where the downspout's going to go, and they would cut with a saw down to that. They would measure then from the string. You set the string 4 inches above the ceiling joist. And so at the other end, you got a 2 inch drop. It's 2 inches above the ceiling joist. You stretch the string taut, and at every joist that sticks out there, you measure down 4 inches and put a mark, and you cut to that. And then when you cut to that, then you use a slope from the inside of the wall and the outside of the board to that mark, and cut those out and line it with a board. And then it was lined with metal. Most of the time it was just lined with metal. This particular has a high dollar Victorian shingle home. So it was lined with copper and soldered together. But over the years, somebody tarred it, filled it full of roof tar, and it caused it to back up and wasn't draining properly. Generally, a box gutter doesn't have that much pitch in it. And so it backed up the water till it found a crack in the solder and came down inside his wall. And of course, the homeowner was unaware that this was going on because it was balloon framing. Balloon framing is the studs go from the sill on the foundation all the way to the rafter. So it just went unimpeded down through there. It wet the back of the sheathing, the diagonal sheathing, and as the sun come out, it drew the water through the boards to the paint. And when it got to the paint, it couldn't pass the paint, so it just peeled the paint off. That's when they noticed they had a problem. The first part of the project was to stop the water leak. Most generally, just like with masonry problems, you don't want to paint the building if it's going to come right back off again. You got to solve the problem. So we got up there and managed to get the box gutters restored and all of them functioning properly. And now it started drying out. I went back on several occasions with a moisture meter and made sure the wood was completely dry before we addressed any further problems. Can you go to the next one? Sure. By the time we got there and it's all dried out, you can see this is the siding and the sheathing, the diagonal sheathing on the bottom, how bad it has got. Problem was that the siding's only 2 3/8 inches, and that's unavailable on the shelf. You're not going to be able to get that. You're not going to be able to find it anywhere. So they were at a loss. They contacted me again. I said, well, you know, this is another situation like the sand. Where did this stuff come from? So we went and took a bunch of photos and looked around. Next photo. And seen that it's tongue and groove. If you can see that this is a tongue and groove board that's cut on a diagonal. After taking measurements, I discovered and some research with Scott's Lumber, which was a local lumber yard, that when plywood became in vague and bigger siding become the way to go, that they needed a market for all this pine, southern pine flooring, subflooring. And so they took it back to the mill and they milled it on a diagonal and ended up with siding boards, basically, that were the size of flooring. So I went to the shop and I found some boards that we'd taken out of a 1900 barn. This is one of them right here, heart pine, and scribed on the side of it that piece of siding. And you can see where it goes. You know, how you can see how it works. And you just set a table saw up on that angle to correspond with that mark, push it through the table saw, and then we end up with, again, then we end up with siding that's made out of the same material, same age, and made exactly the same way that it was done by the lumberyard. And so then we go back and repair, then we can go back and take the siding that's on there off so we can fix the damage of the underlying sheathing and then replace the siding. And so once again, it's history. There's a history lesson. The history lesson, of course, is what, you know, if you own a big lumber yard, and all the lumber yards in West Virginia, when I started doing carpentry work in 1970, they were all local. Most of them had a planing mill inside. Means Lumber. There was a big one in Charleston. In Wheeling, we had Bell Lumber, Scott Lumber, and Haas Lumber, but they all had their planing mills. You're sitting here looking at racks and racks of subflooring, which is pine. It was used in the upper floors for the finished floor, but on all the first floors of all these Victorian homes, this was their subfloor, and then they put oak over top. But it had racks of this stuff, and what are you going to do with it? And so what they done with it is they turned it into siding so they could just get it off the shelf, and ended up all over this beautiful Victorian shingle house in the northern panhandle. So what do we got?
Well, I think that's what.
So there you can see the finished product with the shingle on the left, siding on the right, freeze board on the bottom. These are very typical all over for that time period. These are very typical houses for that time period, about the 1900s, when manufacturing and again, when lumberyards started stocking materials that came from faraway places, made in huge, gigantic mills, and the lumberyards started going away from manufacturing and planing stuff on site.
All right. Got any other topics? Anybody? Have we got any participants that would like to ask some questions?
Yeah, I haven't had any that have come in yet, but if folks have any questions, they can feel free to submit those. Did you guys have anything else that you wanted to go over today? Or I think that was what we had discussed you would do today, right?
Yeah, those were the two topics we had sort of touched on prior. Yeah, and I guess
Okay.
could have filled a lot more time there, but I don't know.
Well, it's kind of hard to know
Maybe-
how these things will go whenever we haven't done one yet. So this is our first Ask the Expert session that we've done.
Sure. I guess we
I think
anticipated a
sometimes
few more
it's easier to
questions as
do in
well.
person too.
Yeah, it's a little more organic that way, but yeah, if there's no further questions there, I mean, that's about what we've got.
Okay, well, yeah, that there aren't any questions at this time, but you all can feel free to reach out to me by emailing info@pawv.org if you have any questions, and I can connect you with Jon or Derrick to help answer those. And I just want to thank everyone for coming to this today. We're hoping that once the pandemic gets under control, that we can start doing these kind of things in person again.
Sure.
And so
Danielle, I'd like to add one thing if I can before we quit.
please
Is
do.
One of the great resources in the Eastern United States is a small college in Belmont County, Ohio. It's called Belmont College. And it's pretty much the entryway into the National Park Service. We put so many students through there into the National Park Service. It is the most well-known and most renowned university or college that deals with the historic restoration preservation process. So that we do have, we have access to instructors in stained glass and finishes, all kinds of paints and finishes. We have blacksmithing, ironwork, and it goes on and on. So if anybody's got anything that's, any questions that relates to anything restoration and preservation, that we got excellent source, just an excellent source for information. And it would like to, if we can go through the Preservation Alliance, it would be great. And we try to get everybody kind of involved in trying to get some of that information out. But we've got there's an excellent program. And if there's anybody interested in a degree in preservation and restoration, there's probably no better place than the small local college that's readily available to anybody. That's what I got on that.
Thank you. Yeah, we're hoping to continue to grow that partnership with the folks at Belmont since they're so close to West Virginia. Well, we haven't had any questions come in, so I guess we'll call it. But if anyone wants to follow up, please feel free to. And thank you all for joining us. Thank you, Jon and Derrick, for being a part of this today and answering the questions that came in ahead of time. And if anyone's interested in joining us again next week, our topic will be completely different. It's more about dealing with policy and in our local communities and at a statewide level. So that'll be next week at 1 o'clock. And then thank you so much. Have a great day and stay safe out there.
Thank you.